Hello, children. How are you all? I hope you all are fine and in good health. Today, I am here to send you a teaching video on chapter sound. I hope it will be interesting for you all and you will learn new things. So, let's start the chapter. Introduction. Sound is important to communicate with one another. In our daily life, we hear different kinds of sound like the sound of animals, birds, and of different human beings. All the sounds are different, some easily are recognizable. Sounds are the bark of a dog and the sound of the whistle of the trains. Different persons have different types of sounds. What is sound? Sound is a form of energy that produces the sensation of hearing. Sound is produced but particles vibrate and move in a pattern called sound waves. Let us perform an activity. Take a plastic scale and paste it on a table so that some part of it projects out from the edge of the table. Place a heavy book on the other end of the ruler and press the projecting end with the tip of the finger and release it. What do you observe? You find that the ruler vibrates and produces sound. Another activity. Take a tabla and hear its sound. After beating the tabla, if you touch the membrane of the tabla, you will feel its vibrations. When the sound stops, touch the membrane again. You do not feel any vibrations now. Another activity. Take an empty big cooking utensil, hit it with a spoon. You can hear the vibrating sound. If you touch the utensil with your hand, the vibrations stop. These activities show that the sound is produced by the vibrations of the medium. If the vibrations are stopped, so sound will be produced. Hence, we conclude that sound is the form of energy and this energy is carried away from particles vibrating above the main positions. In this way, sound travels in solids, liquids, and gases. Sound requires a medium to propagate. Unlike light, sound is the form of energy for which the medium is necessary. Since the vibrating object passes the vibrations to the air molecules, it means that sound travels in a medium. Let us perform an activity to see whether it can travel in a vacuum or not. Take a jar fitted with a vacuum pump and sealed by a stopper. Put an electric bell inside. Allow electric current to flow to the bell in the jar with the help of the battery. You will hear the bell ringing. Now, take the air out by a suction pump and make vacuum inside. Keep the cover tightly on the jar. Now switch on the electric bulb. No sound will be heard. Hence, we can conclude that the air particles were acting as a medium and they were helping the movement of sound energy. When vacuum was created, the sound could not travel inside the jar to outside. Hence, we can say that some kind of medium like solid, liquid, and gas, it is necessary for the propagation of sound. Propagation of sound. When a body vibrates, it transfers its energy to the air molecules around it. On receiving this energy, the air molecules begin to vibrate in exactly the same way as the vibrating body. In this way, the air vibrations reach out to our ears and our eardrum begins to vibrate. The vibrations of the eardrum are analyzed by the brain and we hear the sound. The particles of liquid are more dense than air. Similarly, in solid, the particles are closely packed, hence, the sound travels faster in solid. Sound propagates in all directions. In the morning, when school bell rings, it is heard by all the students, although they are not present in the same place and they are in different places. It means sound travels in all the directions. Its loudness depends upon the distance from source to observer. The louder the sound, the greater is the distance covered by it. A scientist named Ernst Mach was an Austrian scientist who showed that when an object crosses the speed of sound, then there is a loud sound called sonic boom. Today, we know that when a supersonic jet crosses the speed of sound, then loud sonic booms are produced. Today, the speed of supersonic aircraft is given in terms of Mach numbers to honor the scientist. These numbers related the speed of an object to the speed of the sound. In music, there is a scale of light related notes called octaves. The sound produced by these notes are different as their frequencies are different. Let's see the sources of sounds now. First, tuning fork. It is a U-shaped metallic instrument having a stem in between the two prongs. The stem is taken in the hand and the prongs are hit on the rubber pad. The prongs vibrate and produce frequency. The frequencies are written on the stem. It is used by doctors and in practical laboratories. The next topic is musical instruments. There are different types of musical instruments which produce different sounds. They can be classified into 4 types. Now let's see what are those. First is stringed instrument, second percussion instrument, third wind instrument, and the fourth reed instrument. They all produce sound but in different way. First, string instruments. It has 2 parts. One part is wire which when plugged vibrates and produces sound. Other part is the hollow box in which an air column also vibrates with the wire to enhance the sound. You can see the figure. Examples: violin, guitar, sitar, veena. So the sound in sitar, veena, and guitar is produced by the vibrations of stretched string. Second is the percussion instruments. In these instruments, a membrane is stretched tightly over a hollow wooden frame. When the membrane is beaten, it vibrates and produces sound. Examples: drum kit, tabla, dholak. So, the sound of the drum of tabla is produced by the vibrations of its skin membrane when struck. Third is wind instruments. These instruments have pipe-like structure having holes at a certain distance. The air column inside the pipe is vibrated when it is blown from one end. In this way, the vibrations are produced and the sound is heard. Example: flute, trumpet, shehnai, and clarinet. Sound produced by a flute is produced by the vibrations of air enclosed in the flute. Reed instruments: harmonium and mouth organ are the examples of reed instruments. They produce sound when air is blown in it. Now let's see an activity. Sound produced by Jal Tarang waves in water. Take cups of equal size and put different amount of water in them. The space above the cup is an air column of different lengths. When you beat these cups with a stick, the air column will vibrate and different kinds of sound will be heard. An instrument called Jal Tarang is based on this principle. The video was shown. You might have seen the picture of Jal Tarang. Next topic is reflection of sound. Like light, sound also reflects. Sound has a tendency of reflection when it strikes on a rigid surface. In an empty room, the sound given by the source is heard directly and by the reflection also. To understand the reflection of sound, let us perform the following activity. To study the reflection of sound, take a glass container with a wooden lid and put a clock inside it. You can hear the sound of the clock. Now, gradually open the lid of the container. When the lid is at a certain angle around 45 degrees, the sound heard by the observer is more. This happens because the sound waves from the clock changes direction, gets reflected on striking the wooden lid at this angle, and your ear being along the same line of reflection, the sound can be heard more distinctly. This is called reflection of sound. Sound as a longitudinal wave. For a sound wave traveling through air, the vibrations of the particles are best described as longitudinal. Longitudinal waves are waves in which the motion of the individual particles of the medium is in a direction that is parallel to the direction of energy, transport, or wave propagation. A long wave can be created in a slinky. This is a slinky. If the slinky is stretched out in horizontal direction, the first coils of the slinky are vibrated horizontally. Sound waves in air and any fluid medium are longitudinal waves because particles of the medium through which the sound is transported vibrate parallel the direction that the sound wave moves. The result of such longitudinal vibrations is creation of compressions and refractions that are within the air. You can see in the figure. The next topic is absorption of sound. The absence of an echo means that the sound waves are absorbed and not reflected back. The controlling of echoes in a building is called acoustics. When a sound wave strikes on one of the surfaces of the room, some of the sound energy is reflected back into the room and some penetrates the surface. Parts of sound wave energy are absorbed by conversion to heat energy in the material while the rest is transmitted through. Sound energy is absorbed by acoustically soft materials that sound waves enter. An open window is the example of round absorption, that is, no reflection, whereas in bathrooms they have hard reflecting surfaces and therefore very low sound absorption properties it has. Now we'll see sonar, an application of echo. The property of reflection of sound is utilized in sonar sound, navigation and ranging, which produces and receives ultrasonic waves after reflection from an obstacle. It is used in ships, submarines, etc. to measure the depth of the sea. Let the distance between ship and obstacle be y. Time taken to cover total distance to y is t. Speed, you know what is the formula? Speed is distance upon time. So here distance is 2y upon t. Hence y is equals to s into t by 2 by cross multiplying. Here s is the speed of sound in seawater, which is 1560 meter per second. I hope it's clear. The characteristics of sound. The sound has three characteristics. First is loudness or intensity. Second, pitch. Third, quality or timbre. Now we'll study individually. Loudness. It is the characteristics by which a loud sound can be differentiated with a faint sound. The loudness of sound depends on amplitude. If the amplitude is high, the sound will be louder. Otherwise, it will be a faint one. You can see the waves in the figure. It also depends on the distance between source and the observer. Surface area of the vibrating body, density of the medium, and pressure of resonant bodies. The figure A, which is on your screen, represents loud sound because amplitude here is higher. Pitch. It is the characteristics of sound which distinguishes a shrill sound from a flat sound. Pitch depends on frequency of sound. If the frequency is high, pitch is also high. That is why female voice is shriller than a man's voice. You might have observed this. The figure B represents high pitch because of high frequency. Now, quality or timbre. It is the characteristics which differentiates between sound produced by two instruments having same pitch and loudness. Example: sound produced by guitar and sitar, and also sound produced by dholak and tabla are different. We can easily differentiate them. Different sounds of two instruments without seeing them, because different instruments have different quality of sound. Sound quality is known as timbre. Do you know? Sound can travel through solids, liquids, or gases. It cannot travel through a vacuum because there are no particles to vibrate and carry sound waves. Thank you, children. I hope today's class was interesting and you got a lot of things to learn. We'll meet you soon.